was requested by Professor Chu to do a presentation, which is a tour of our pharma processing complex. At the same time, it also shows you some of the challenges we face so that you can look at whether you want to do any plant design projects based on these. Okay, this shows you the contents of my presentation for today. It will show you the location. We've got some bird's eye view of the site, and I'll show you the basic process flow. And then I'll show you the products that are produced on the site, the facilities on site, and the capacities as well. And I'll show you pictures of the various plants, and then walk you through the palmitic and lauric process flow. There are two types of oils. I'll explain that later. Then a more detailed refining process flow and a fractionation process. That will be followed by videos showing you the refining and fractionation process. Then after that, I'll go to the palm kernel process. This complex has got also palm kernel. So I'll also walk you through the palm kernel process. Then I'll share some kernel crushing plant where the palm kernels are processed. It's called the kernel crushing plant, or KCP for short. Share some of the performance data. Of course, these are things that we always try to improve. Then I'll follow that up with a video of the kernel crushing plant. And yes, this is a new area, elements of Industrial Revolution 4.0, also areas that you may want to look at in your design projects. Then I also will share with you the usage of palm products, the health benefits of palm oil, some awards that we have won, and I'll also show you some of my team members. Now, the challenges faced. One of the major items that we face now is sustainability. So whatever processes that are being put up today must address this issue as well. And even whatever existing process that we have to look at reducing our carbon footprint. We say either the GHG, greenhouse gas emission, or the carbon footprint from that plant. So you have to look at redesigning processes, and this is becoming a very interesting area of development for engineers to look at. Quality, of course, is always of concern. In the refining process, there are process contaminants that are produced. So we've also got to look at how we can reduce the production of these, inadvertent production of these contaminants, such as the trans fatty acids, the 3-MCPD, the glycidyl ester, and mineral oils that contaminate the food products. A new area to look at is enzymatic processes to replace the more energy intensive physical refining and fractionation process. And again, Industrial Revolution 4.0 and the implementation of artificial intelligence so that we can actually optimize the operation of the plant. Okay, where are we? We are in Sandakan. This is our location over here. The light green and the dark green that you see here are many of our IOI estates and mills, and they all supply their products to our location here in Sandakan. We also buy from third parties, not only IOI mills, but mainly around the Sandakan region. From this area, they supply here. The ones further south, they supply to refineries in the Lahad Datu region, and further south to either Tawau or to Kunak. This bird's eye view of the complex. What you'll see here are catchment ponds. We don't have water supply from Jabatan Air Sabah, so we actually have catchment ponds. We collect surface water. We also do a lot of rainwater harvesting, and we have our own water treatment plant to process our own water. Even the water that I drink here is treated by my own plant here. This part here is the biomass complex, which I won't be explaining much about today. This plant produces steam and electricity to power this whole complex. This is the IOI edible oils complex. This is the raw material storage yard for the biomass plant. Here are, this is a tank farm, a huge tank farm, about 64 tanks here, with a capacity of 175,000 tons. And we have various plants here. This is the refinery complex. There are 3 refineries here. There are palm kernel dry fractionation plants here. There are fractionation plants here, and kernel crushing plants here. These are just warehouses for storing the products. The reason I showed this picture as well is to show that we actually have a jetty that's connected to our site. So the products from these tanks, the liquid products, are exported directly through the nearby jetty. Yeah? We actually operate the jetty. It is owned by Sabah Port now, but our men man it, do all the loading into the tanks on the vessels. A view of the plant again, you'll see a ship coming into dock at the jetty, right? And this is the view of the ponds in the foreground, the tank farm, the various plants in the complex. This is a ship that is at the jetty. We have got dedicated pipelines to load various cargoes onto the vessels that come along here. These are ocean-going vessels that deliver to Europe, China, and various other destinations. Now, this is a typical supply chain. We have CPO and crude palm kernel oil. CPO is crude palm oil. CPKO is palm kernel oil. And palm kernel that comes into the facility. It goes through the receiving station after quality tests, goes to storage, then it's processed in either refinery or the kernel crushing plant. Then the products go to the storage tanks, and then by pipeline is delivered onto vessels and exported out of the country. This is a list of some of the products that we produce here. We have RBD palm oil and RBD palm stearin. RBD means refined, bleached, and deodorized. The crude oil that comes in goes through this process to make it refined, bleached, and deodorized. I'll explain the process later. We have palm oil and palm stearin. We also produce refined, bleached, and deodorized palm olein and other grades, higher quality grades of olein. On the lauric side, we have crude palm kernel oil, crude palm kernel olein, and crude palm kernel stearin as products, or we refine it and sell it as refined, bleached, and deodorized palm kernel oil, refined, bleached, deodorized palm kernel olein, and refined, bleached, and deodorized palm kernel stearin. The co-products, or byproducts, some people call it, are palm fatty acid distillate, which is removed during a distillation process, and palm kernel fatty acid distillate to separate or distinguish between what comes out from the crude palm oil refining and what comes out from the crude palm kernel oil refining. The co-product of the kernel crushing plant is palm kernel expeller. And we have various grades of oil for sustainability reasons. This is a round table on sustainable palm oil. This is Malaysian Sustainable Palm Oil Certified oils, and both for the palm and palm kernel oil. So all these various grades are stored. You'll remember I showed you we've got many tanks here. We have to segregate and store them in different tanks according to their grades. I told you I'd share the facilities that we have over here. These are the main facilities and many other supporting facilities. We have 3 refineries here with a total capacity of about 1 million tons per year. There are 4 dry fractionation plants for the palmitic oils. The 4 with a capacity matching the refining capacity, which is about 1 million tons. Currently, we only run 3 plants because we've upgraded 2 of the plants through optimization to still achieve the same capacity. So only 3 plants now are needed to run in the fractionation plant to supply the same capacity. We have 3 kernel crushing plants with a capacity of 300,000 tons per annum. We have 2 palm kernel dry fraction plants, 120,000 tons per annum. Like I said, we have a huge tank farm, among the largest in Sabah, and also we are one of the largest exporters of oil out of Sabah. Storage capacity of 175,000 tons. We have our own effluent treatment plant with a capacity of 365,000 tons per annum. Like I said earlier, we have our own raw water treatment plant. So all the requirements for this whole complex is met by that raw water treatment plant, including up to potable water, even for the lab requirements. We have a very strong research and development department here, which has worked on designing experiments for 3-monochloropropane diol ester and glycidyl ester mitigation in palm oil. These are process contaminants that are formed in the refining process. We've also worked on improving our dry fractionation yield, controlling our trans fatty acid production in the plants. We've also been studying on reducing our mineral oil saturated hydrocarbons and mineral oil aromatic hydrocarbons content. And we've also worked on using our co-product from the palm kernel plant, from the kernel crushing plant as animal feed. So we've got quite an active R&D department with a lot of equipment. This is pictures of the plant. What you see here, with each of these towers sitting up here, are the refineries. You've got refinery 1 here, Refinery 2 and Refinery 3. Nestled within the plant in the lower section is a dry fractionation plant. So the dry fractionation plant 1 here, 2 and 3 side by side, and then 4, dry fraction 4 is built together with Refinery 3. What you see over here, this is the CPO or the receiving sampling point, sampling station, where any incoming material is sampled and the samples are dropped to the lab. The lab is just next door to the sampling station before it can go to the receiving station for unloading its cargo. Next to it, you see the palm kernel dry fractionation plant. There are 2 plants here. And in the background, you see the tank farm. And you see the Sandakan Bay in the background, the Sandakan Bay. Here are the kernel crushing plants. You'll see their own silos here. They are solids, so they don't share the same tank farm as the liquid cargo. This is solid. Palm kernel is stored in these silos here. There are 3 large silos and 6 smaller ones with a total storage of about 9,000 tons. And they supply the 3 kernel crushing plants here. We have a maintenance team here for both electrical and mechanical, and we have a central store also here. This is a view of the tank farm and the palm kernel dry fractionation plant. This is the laboratory, and this is what I told you just now, where the CPO is received after it's passed its quality testing. This is again a view of the refinery, and this is the fractionation plant. The fractionation plant, the heart of it is the filter presses and the crystallizers. It's a highly batch operation. So an area for you all to look into is how you can make this a more continuous operation. There are requests for moving it more towards continuous operation rather than this batch nature of the current dry fractionation plant. It's called dry because there is no solvent used. In our facility here, no solvent is used for extraction. So it's a dry fractionation, which I will explain the process to you later. Okay, what you see, can I close this? Okay, this shows you the process flow of what comes into our factory. In the mills, palm fruit is processed and you get 2 products, which are crude palm oil and palm kernel. So this green color are the mill products. The crude palm oil, I will handle that section first. The crude palm oil goes to the refinery where it goes through the degumming and bleaching process, and you get what is called bleached palm oil, which then goes to the deodorization stage to produce refined, bleached, and deodorized palm oil. And the core product is palm fatty acid distillate, as I mentioned to you earlier. It's a byproduct or co-product. Now, this can be sold as a product, or it can go for further processing called the dry fractionation process. What the dry fractionation process really does is it splits the oil into what would be a liquid at room temperature, which is called the olein, or refined, bleached, and deodorized olein, and the solid, which is refined, bleached, and deodorized stearin. So we split it in a fractionation process, which I showed you earlier, or I'll explain again later. And these are again final products. Or in some cases, we have special requirements from customers. So it goes through another fractionation stage to produce what is called super olein. So this is another area where you can look at to see how you can go from here to here in a single stage to look at design of the process. Now, where do you find these products being used? You'll find this side is the palmitic. You'll find that palm oil is used for bakery fats, for biscuit fat, and food service in the frying oils. Olein, the liquid fraction here, is used for most of your chips and also for a lot of cooking applications. Super olein can be used for more specialized applications. Then we have the stearin used for things like spreads, like margarine, confectionery, can be used for making soaps. And here you have the palmate fraction can be used for making the creamer that goes in between these cakes for certain ice creams and even for frying purposes. Now that is the palmitic side. Now the other side, the palm kernel, that side is called the lauric side. Palm kernel oil is termed as lauric oil. The palm kernel is a small seed that goes through crushing. The crushing operation removes the oil. You get crude palm kernel oil. And the core product is palm kernel expeller. The crude palm kernel oil can be a product by itself, or it may go for dry fractionation to split it into its liquid and solid fractions called crude palm kernel olein and crude palm kernel stearin. or the crude palm kernel oil can go straight to refining. All of these then can go to refining stage as well, where you have degumming and bleaching being done, where we get the bleached versions of the oil. Next is the deodorization, where we produce refined bleach and deodorized palm kernel oil, refined bleach and deodorized palm kernel olein, refined bleach, deodorized palm kernel stearin, and the co-product, which is palm kernel fatty acid distillate. Now, if you look on the right-hand side here, this shows you the application for many of these products, and you'll find that you use it on a daily basis. See, a lot of the creamers or whiteners that I use are actually from palm oils or palm kernel oils. Again, for ice creams, confectionery. Palm kernel expeller here is widely used for cattle feed because it is very good for fattening cattle and also for increasing its milk production. The palm kernel oils are also used, again, widely used for confectionery, whereas the fatty acid distillates are used for animal feed as well as for making detergents. So you'll notice that you use a lot of these products on a daily basis. Now, this is the refining process, which I will walk through step by step, so it'll be easier for you to understand. Okay, we get CPO coming from the storage. It is heated up in the plant. We have heat exchangers here, which uses heat recovery or steam. And the heated oil then is dosed with phosphoric acid because the oil contains gummy matters to degum it. It then goes into a degumming vessel where there's some retention time. And the degum oil then goes into a bleacher where bleaching earth is added. It's a bleaching agent used to remove the impurities in the oil. Again, there's retention time involved here. So these are areas for process design or plant design work to look at how I can achieve this faster. Again, there's steam being inserted for agitation purposes. After bleaching operation, there is a filtration that takes place using a concept called a Niagara filter. It's a pre-coat filter. I'll show you the operation later. Then to ensure that all the bleaching that is trapped, it goes through some polishing filters. Then it goes into what is called the bleached palm oil tank, which is under vacuum. This is then fed through a series of heat exchangers to heat it up to the final heating temperature to feed it to the pre-stripper. Here, the final stage of heating is done using a closed-loop boiler under controlled temperatures. It's a closed-loop boiler using water, basically, at 260 degrees. This is our deodorizing temperature. Then the heated oil is fed into the deodorizing column, the pre-stripper, where steam is inserted to remove the volatiles. Here as well, you'll see the volatiles coming out. It goes into a stripping system. Steam is generated using a steam ejector system. Then you have the oil from the pre-stripper going into a 9-tray deodorizing column, absorption or stripping column. This is a pack column, whereas this is a tray column, and it goes through an overflow system to go through tray by tray by tray to come down here as the refined oil. You'll notice we've used different colors here. This is the crude oil, which has a darker color. Once it goes through the bleaching operation, it comes out with a lighter color. And when it comes out from the deodorizer, it achieves its final color, which is almost very light color, which you see in the supermarkets. The deodorizing is also done using steam stripping in order to remove the volatiles. And also the high temperature is used to break down the color-causing components in the oil. The oil that comes out from the deodorizer goes back through these heat exchangers for heat recovery purposes, and then goes to a final polishing stage before it is sent to the storage tank as final product. If you want, you may want to take a picture of this to show you the refining process, and it also shows the legends of the various streams in the process. Okay, I'll move on. Okay, this is the dry fractionation process. The dry fractionation process, like I told you, is a batch process. Oil comes in, is fed in a feed tank, is heated up, and then is fed to, these are crystallizers. It goes to each crystallizer one at a time. And each of the crystallizers have got a jacket and cooling coils inside, which follows a very strict program to allow crystallization to take place stage by stage to optimize the crystal growth. And when each crystallizer is ready to drain, one by one they are drained and sent into a filter press. What you see over here is we have a chill water system which is fed to the jackets to cool the oil in the crystallizers to achieve the final desired crystal size as well as final draining temperature. The palm oil slurry that's fed into the crystallizer, which has got membrane filters and filter cloth, separates the liquid from the solids. The liquids come out and the collector as olein. The solids are trapped in the filter, after which it goes through a squeezing step to try and remove as much of the olein as possible to get the cake as dry as possible. Then this solid is discharged into a tank. This tank has got heating coils in it to help melt the stearin, and then this is sent to storage tank. You'll see here we've also got a circuit where the olein is fed into a tank for heating it up for flushing purposes. And once a day, the cloth is flushed with hot oil in order to prevent any buildup of solids, stearin, in the filter press. The crystallization is done starting at about 60 degrees, and there is a cooling curve that brings it down to about 23 degrees Celsius, and that is when it is actually drained into the filter press. So once it's drained here, these are all going to be solid. So it takes heating to melt it to be able to pump it to the storage tank. Okay, now I will play the video for you to appreciate more of the equipment that is in the plant and the process as well.
Palm oil processing start from degumming, bleaching followed by deodorization to obtain RBDPO and PFAD. Olein stearin through dry fractionation. This is our refined palm oil product, RBDPO, PFAD, and various specification of olein and stearin. Typical supply chain start from incoming CPO, production, and outgoing shipment. This is our CPO receiving station. Next to it is a laboratory running for 24 hours for quality control assurance and oil sample analysis. Physical refinery plant process CPO into RBDPO. For physical refining of crude palm oil, the first main process is the degumming of CPO. CPO is mixed with phosphoric acid in order to remove gums in the oil. Next, the oil will go through a bleaching process where undesired matters will be absorbed by the bleaching earth. The slurry will then be filtered out by the pressure leaf filter. After that, the bleached palm oil will undergo deodorization process to lower free fatty acid content and improve oil color. The crude palm oil is drawn from the tank farm, and after that the CPO will exchange heat with the outgoing refined, bleached, and deodorized palm oil from the process through plate heat exchanger. Degumming of crude palm oil is the mixing of CPO with phosphoric acid to improve oil flavor and color, and to extend the shelf life of oil. During bleaching process, bleaching earth is dosed into bleacher to absorb unwanted matter such as color pigments, heavy metals, and precipitate from degumming process where steam sparging is used for agitation. After the bleaching process, the slurry oil will be sent to the pressure leaf filters to remove the bleaching earth. The slurry oil will first undergo pre-coating on the filter leaves before proceeding to filtration process. When filtration is completed, steam is continuously blown into pressure leaf filter to dry the cake, and vibrator cylinder vibrates the dried spent bleaching earth. Pressure inside the pressure leaf filter is removed prior discharging the spent bleaching earth. Here is an explanation video showing how the pressure leaf filter operates in details. Filter leaves are arranged in spherical shape. Bottom of filter leaves are locked in position. A metal bar connects all the filter leaves to the vibrator cylinder. Slurry from bleacher starts to enter and fill up the vessel, and the slurry is recirculated to form a layer of coating onto the filter leaves. Filtration process starts after pre-coating process is complete. Bleaching earth are filtered out from the BPO. Steam is blown into the filter to empty the oil and dry the spent bleaching earth.
This one is sent to the slop oil tank, the final amount.
Vibrator vibrates the filter leaves and spent bleaching earth is discharged from the bottom. BPO coming out from the pressure leaf filter goes through the bag filters and cartridge filters for polishing steps. BPO proceeds to final stage of physical refining, deodorization. Through the sight glass, we can observe the vigorous mixing of the oil where FFA and other volatiles are stripped off with steam
That is due
rising
to steam,
forth.
that is due to steam.
This is another type of sparging steam using mammoth pump.
Line steam is injected into the oil under vacuum conditions, almost absolute vacuum.
The stripped FFA is condensed as PFAD in distillate recovery system and collected in the fatty acid tank. Engineer and operator can do monitoring in the plant control room and fine-tune the process. Cooling tower's function is to cool down the water gets heated up by the plant equipment. This is the high-pressure closed-loop boiler for high-temperature oil heating for deodorization process. This is the control panel of the boiler. The boiler chimney outlook.
There's some heat recovery here. It's new. We just put it in recently.
Flue gas economizer was installed at the outlet of the boiler to recover heat and to reduce steam consumption. LNG burner supplied clean fuel for the boiler. Vacuum is generated by the compression of steam through the steam booster and is being condensed by the barometric condenser. Whatever condensed by the barometric condenser will go to the hot well to separate oil content and cool down before it is sent to the dirty cooling tower where the non-condensable will be removed by the vacuum pump and released into the atmosphere. Now moving on to the dry fractionation plant, where palm oil is separated into olein and stearin.
The background here, the crystallizers, this is the filter press. It's a membrane filter press. See, there are two plants here, two filter presses. These are crystallizers on either side. The crystallizers.
This is the process flow of dry fractionation. First, good quality RBDPO with targeted color of 2.7R is supplied from refinery plant to dry fractionation plant. Next, the RBDPO is preheated up to around 70 degrees Celsius before sending into the crystallizers to destroy the crystal memory. In the crystallizers, the oil is cooled following a cooling sequence with defined program using PLC or programmable controllers. Then the slurry oil is sent to the filter press for the separation of liquid and solid products. The crystallization mechanism starts with nucleation where small crystals are formed. Once the crystal nucleus is formed, it starts growing due to the incorporation of other molecules of the edges and liquid layer. That is continuously filled by the supersaturated liquid that surrounds the crystals, resulting in the size of the crystal increases. Next, agglomeration occurs where the crystal sticks together, and last mechanism is attrition where the agglomerated crystals break into small pieces due to the mechanical collision. Cooling water and chilled water will flow through the water cooling coil in the crystallizer to cool down the oil according to the program sequence.
These fins are actually water cooled. They're filled with water. This is the agitator.
Crystallization is being done in the crystallizer where it is being programmed to follow a controlled cooling with specific agitation speed to form good crystals. In dry fractionation plant, chiller is an important machine since the process depends on the chilled water for crystallization to occur. Oil slurry from crystallizers is fed into filter press for filtration.
There's a slurry going in the filter press.
The liquid olein is being filtered out through squeezing using air or oil. Upon filter plate open, dried sphere and cake is being discharged. Stainless steel plates are installed in the stirring tank to break the stirring cake into smaller pieces to ease the melting process before sending to storage tank. This short video demonstrates how the membrane filter press operates.
There's a slurry coming in, right? Cake starts building up. The olein goes through, comes out through the outlets. The cake builds up, becomes quite thick. Then core is blown. Then air comes in to squeeze the membrane, to squeeze out the olein and compress the cake. Then the air is released, and then the plates are shifted to allow the cake to fall down to the trough at the bottom. Then the next cycle starts again.
Clean and stirring are collected at the plant collection tank prior sending to their respective storage tank at tank farm, following the daily QC planning. This is our bulking installation for the storage of RBDPO, CPO, olein, stirring, and crude lauric products prior shipment. Here is a list of our certifications in place to meet the domestic and international standard requirements.
Okay, now another thing that we've actually done in our plant here is we've actually installed centrifuge. We were among the first companies in or refineries in Malaysia to go to do CPO washing, in order to reduce or remove the impurity in the oil in order to mitigate the formation of 3-MCPD. Here I'll show you how it operates. Here's a disc stack inside the centrifuge. The slurry comes in here, the oil, the CPO comes in here. Travels all the way down. So it splits into these spaces and travels upwards through the disc pack as clarified oil. There's a space at the side for collecting and accumulating solids. So once the solid builds up over here, the piston will shift to open the gap and purge out a lot of pressure inside to purge out the solid. It's all done automatically by the centrifuge, and it closes back again and resumes its centrifugal operation. Then the clarified oil moves upward. To the liquid leaves the clarified liquid. You see the lighter color again, when clean up, and goes on to further processing. The purpose of doing this washing is basically to remove chlorides. The intention being to reduce the formation of what I told you earlier, the contaminant 3-MCTB. Okay, now for palm kernel oil, I've already covered the palmitic side. Now I'm going to explain a bit about the palm kernel processing. The palm kernel looks like this. The kernels are received in silos. It goes through a first pressing stage. Oil is collected. The cake that is formed from first pressing goes to a second pressing stage with slightly different configuration than the first stage to produce more crude palm kernel oil. Actually, the kernel comes in with about 52% oil content, and we are able to obtain a yield of about 47% oil, and we get the balance as palm kernel expeller, and palm kernel expeller will contain about 6 to 7% of oil in it. That oil, which I forgot to explain earlier, the fatty acid composition is very similar to that you have in mother's milk. So it is very widely used for infant formula. Here, extracts from it are taken to supplement into infant formula milk. The palm kernel expeller, which I told you was used for animal feed, is also for the same reason, because the fatty acid composition mimics that of in mother's milk, breast milk. So it is very useful for cattle feed, not only for fattening the cattle, but also for increasing the milk production. So the PKE, the palm kernel expeller, or cake, is stored in warehouse, then shipped off. The crude palm kernel oil goes to filtration, to storage tank, and then it may go to the palm kernel dry fractionation plant for splitting into palm kernel olein and palm kernel stearin. And along the sides, you will see the various products that can be made from the lauric oils. And now, if I can just explain a bit, this orange portion here is where crude palm oil comes from, right? This orange portion is called a mesocarp. The crude palm oil, this orangish color, is because of the very high beta carotenes in crude palm oil, whereas this central portion with this brown, dark brown hard case and the white meal inside is where the palm kernel oil comes from. If you look at this, this is very similar to coconut. And in fact, the properties of palm kernel oil are very similar to that of coconut oil. And in a lot of industrial applications, palm kernel oil is replacing coconut oil because there isn't a lot of replanting of coconut oil going on, and it's difficult to harvest that crop, whereas palm oil is easier to handle. So there's a lot more palm kernel oil replacing coconut oil in industry. This is what the kernel crushing plant looks like. You have the first pressing and the second pressing lines. These are dust collecting units. These are our dust collecting plants. This is another plant. We have the first pressing, second pressing. The second pressing, we have a series of presses, which are called swing presses. We can either do first or second pressing. If there's too much cake to handle, then they will be doing first pressing job. If there's less cake available, they will do second pressing. Otherwise, they'll just be idle. I'll share a video with you on the kernel crushing plant.
As a part of IOI Edible Oils, the kernel crushing plant KCP, engaging in producing crude palm oil CPKO and palm kernel expeller PKE. The raw material used is palm kernel PK, which supplied from various mills. As for today, KCP's processing capacity is 950 metric ton of PK per day to fulfill the increasing demand for CPKO. The receiving station is responsible to arrange PK, unloading work, storage and stock estimation. Prior unload, all PK are subjected to quality test by Quality Assurance QA department. Besides analytical test, visual inspection of PK also carried out. Upon approval from QA, trailers permitted to unload. From PK unloading, hopper, conveyor and bucket elevator are transmitting the PK to silo. Currently, there are 6 silos with a nominal storing capacity of 500 metric ton each, and 3 silos of 1,250 metric tons each. PK in silo directed to use by first in first out basis. KCP management will determine which PK silo to be consumed by plant on daily basis.
This is a destoner for removing stones from the palm kernel.
From PK silo, PK is being transferred to plant via screw conveyor and bucket elevator. PK is then loading into the first pressing hopper. The hopper is feeding the first stage mechanical screw press to extract CPKO from PK. Oil and cake is separated by press body cage of 1 mm width and less. Solid output of cake will be conveyed to
This is for the first pressing, this is second pressing.
conveyor and bucket elevator to repeat same CPKO extraction process in the second stage mechanical screw press. CPKO will be directed via screw conveyor to oil buffering. Unfiltered CPKO will be banked into underground tank and served as buffer for the next process. Unfiltered CPKO pumped to vibrating screen at sieve 60 micron and larger particles by vibrating screen. Conveyors move all the OLI solid residue to first pressing station, filtered CPKO drained into unfiltered tank. Heated CPKO undergo filtration process at Niagara filter. Pressure vessel maximum at 3.0 bars, it will separate 112 to 125 micron particles from oil. Clean CPKO pumped to buffer storage. Oily solid residue of filtration is conveyed back to second pressing station. After filtration, clean CPKO flow to buffer storage tank. The pipeline to storage tank is blown clear using compressed air. Trapping 200 micron particles in CPKO is double the guarantee to ensure impurity level is below 0.020% before pump into storage tank. Trapping metal debris in CPKO using magnet before pump into storage tank. From buffer storage, CPKO will be diverted to bulk storage tank. CPKO quality is monitored by QA. CPKO will be shipped as final product or being processed further in palm kernel dry fractionation (PKDF) or refinery. Meanwhile, dust collecting system is installed to recover finer PKE back to second pressing station, besides to provide good working condition in plant. On the other hand, solid output from palm kernel expeller (PKE) is transferred to metal magnetic screening. PKE oil content and moisture will be controlled ideally. PKE that's sent to warehouse will go through extra quality assurance with magnetic screening. Soon it will be exported as animal feed. During storage, moisture and temperature of PKE are being monitored daily. Prior to PKE shipment, sanitation inspection on all transshipment equipment will be carried out. From warehouse wheel loader transfers PKE to trailers. The trailers will unload PKE to vessel via portable belt conveyor at the local port.
Okay, now this is some of the data from the kernel crushing plant. You'll see we had done quite a bit of improvement in the plant to increase the yield to the level that we reached here. During COVID, there was something that happened to the quality of the oil and our kernels, and we saw a decline in the yields, but it's now climbing back up again, back up to the records we achieved earlier. Unit power consumption. Power is the largest unit utility that's consumed in this plant. And we've actually managed to reduce it significantly through a lot of improvements being done in the plant. Repair and maintenance has also another area that is a very high cost, and we're trying to actually bring it down. Unfortunately, with the weakening of the ringgit, a lot of our material costs have actually gone up, so, impacting us as well. Now, you will often hear that palm oil is not a sustainable oil. I just wanted to share with you that palm oil is actually a very efficient crop. You will notice that compared to all the other crops, it only occupies 6% of the total land used globally for vegetable oils. And yet it produces 36% of total vegetable oil production. If you compare the next closest, which is soybean, it actually uses 40% of the global land use of vegetable oils, but it only produces 26%. So if you want to convert all this oil into soybean, you'll find that you'll need a lot more land, and you'll have to clear a lot of forests, which is going against sustainability initiatives. If you look at all the other oils, they are not as productive as palm oil. This is another way of looking at it. If you look at palm oil, it is only planted on 77 million hectares, right? Sorry, if you want to meet all the global vegetable oil demand, right? You only need to plant palm oil on 77 million hectares. Whereas at the same time, for soybean oil, you need 490 million hectares, about 7 times more land than palm oil. So you can see it is a very efficient crop. And again, I'll show you again, if you compare soybean oil, for producing 1 ton of soybean oil, you need 2 hectares of land, whereas you only need 0.26 hectares of land to produce 1 ton of palm oil. Or if you look at the tons of oil produced per hectare, 0.5 tons of soybean oil is produced per hectare, whereas 3.85 tons of palm oil is produced. And you can see all the other oils are far, far more inefficient than palm oil. As part of our sustainability initiative, also we run our own effluent treatment system where the water is actually recycled. See, the refinery uses water for its process. It sends the water, the effluent water is sent to the effluent treatment plant. It's treated and sent back. This doesn't come into contact with food. It's only for vacuum generation purposes. So it is completely separate from the food section, but it is recirculated. There is very little water wasted in the complex. Even the reverse osmosis water system that we have in our plant, the reject water is also totally used in the plant. You'll notice here we're using solar panels for powering up sensors that are located outside in the effluent treatment plant. Even the aeration in the reactors was shortened from 16 hours down to 3 hours, still achieving very well within the limits imposed by DOE. DOE limits are 200 ppm COD. Our target is below 100 ppm COD. And because we also supply it back to the plant, it is imperative that we keep it very low. So here you'll see that we monitor the amount of water that we reprocess. And we've also gone for shorter cycle times without sacrificing on the quality of the treated water. Now the solids that are generated, which are mainly organic, are sent back to the biomass boiler for combustion as well. So there's no waste from this process at all. The process use aeration, and we have a DAF tank, dissolved air flotation tank, and then it goes through a sequential batch reactor where nutrient is fed to the bacteria, or bacteria is cultivated and maintained inside these reactors at optimum conditions. So you'll see the incoming water looks like this, whereas the treated water comes out in this form and is sent back to the plant. And you'll see we also monitor our electricity consumption. We're working on reducing it even further. You see the amount of water processed and the kilowatt hours per ton effluent process. You see we're trying to reduce it further. This water recycling, like I said earlier, we even recycle the reject water from the reverse osmosis plant. And you'll see we're targeting to use more and more of the effluent treated water. Some of the areas where we use the water are for washing purposes, for firefighting purposes, and even for some cooling towers, the dirty cooling towers. This is our CPO sampling station, how our products are handled when they come in, and the raw materials are handled when they come in. I'll just play the short video for you.
CPO incoming and receiving settled from incoming tanker arrive at the sampling station, then sample taken by the lab operator for the quality analysis at the lab. Then you will proceed to discharge at the receiving bay. At the sampling station, the incoming tanker arrive shall level on the sampling platform before sampling commence, as inspected by the duty officer. A main system in place enable easy and fast checking of the arrived tanker, which included lorry number, tanker number, supplier name, and also cargoes carried.
So capture on those cards.
Checking for the serial number in the screen with those on the tanker. Simply by cutting in the details report out for viewing and selected info to be printed out into a sticker, which being labeled onto the sampling bottle as the first step of sample registration in lab. Checking and also seal breaking attended by sampling operator together with the duty officer. Watch a short video showing the tanker moving into the sampling station while another tanker waiting for sampling.
Okay, sampling going on, a tanker is coming in.
By using a stainless steel sampling can, sampling operator started collect sample of composite and also the bottom sample from the tanker. These samples are transferred into a sampling bottle, which labeled with sticker that printed with details. These samples are then sent through a dedicated chute from sampling station into laboratory for quality checking.
So just drop in here and it goes into the lab. Goes right into the lab.
Upon receipt sample, lab operator will first check the details on the label and then proceed for quality tests, which included free fatty acid and moisture, ball rabbit, and IR scanning, and Dobby by using a spectrophotometer. Results are updated into the system and proceed to pass for discharge. Follow sequence at the reading zone. Quality pass tanker proceed moving into a receiving bay. Follow the grid of the oil. They are dedicated receiving bay for certified oil such as RSPO, ISCC methane capture, and both CPO. Different bay available also for normal CPO and also CPKO. The pass tanker will move into the receiving bay. Here at the receiving station, operator will first check the details of the tanker through the unmanned system to ensure certified oil is directed to the dedicated discharge bay. And here showing the cycles for the CPO receiving in progress.
There's a moisture detector here as well with alarm in case there's too high water level in the CPO. And now the valve has been automated. It will close immediately high moisture levels are detected. We have an unmanned system here. I think I'm running out of time, so I will not play these videos here. Just now you saw the smart tags, right? Basically, we implemented the system a few years ago where you observe over here, you'll see the tanker is coming in. The driver doesn't get out from the tanker. You'll see he drives in. He will throw his smart tag at a card reader. The gate will automatically open. There you see the gate is opening. Then he drives onto the weighbridge. And once he's properly parked, the gate will close, checking all the sensors. Then it will take the final weight before the discharge gate opens. Then he's allowed to drive out. Just takes a few seconds. It's all done without the driver having to come down from the lorry. Right. So he has to do some preliminaries at the guardhouse to register, and it also screens out whoever what's it called, unauthorized to enter our premises. They're having fake IC driver's license. The system captures it. Okay, in another area that is of interest is the implementation of Industry 4.0. We've done quite a bit in our kernel crushing plant. You'll notice here we have vibration sensors we put in. We check the oil content using a near infrared machine for each of the presses. It is analyzed twice or 3 times a day. Then we have the amperage of the presses being monitored live with information being sent back to the operators if it is operating suboptimally. Water flow is also monitored because water is to be added back into the kernel crushing plant to avoid overheating and also fire. We have sensors to monitor the levels inside these silos. We have smart meters installed at many areas to monitor the power consumption of the plants and also for the air compressors. And we also have vibration sensors for the predictive maintenance. And I'll show you some screen grabs of what is done. We have the predictive maintenance dashboard here, showing you the pumps that are operating under danger conditions, which are on alert and which are okay. So green is okay. Yellow is already alert, whereas red is in danger, which means it highlights to the operators or the engineers that we need to do maintenance work on these pumps. So these are the various plants: dry fractionation 1, fractionation 2, dry frac 3, dry frac 4. So this shows you the number of pumps in critical condition and those which are operating optimally. This is PHM, Prognostic and Health Management, where we put in predictive maintenance tools in order to try and sense what is happening in the plant so that we can take corrective action before serious damage takes place. So they have vibration sensors that we put in, so it actually helps us to monitor the condition of the plant, whether it's running under danger conditions or not, right? So it monitors and gives us feedback on the conditions, even the amperage. If it is running at a suboptimal amperage, also it gives us certain information. This is a customized cyber physical system for monitoring the power consumption of the various plants. So you have the power meter status, vibration sensors, the sensors telling us the status of all these equipment. Even our press, how many presses in a particular plant are running. See, this is KCPB, the blue color is KCPA, sorry, has got 39 presses running. And KCPB has got 37 presses running. So the others are down. There's 1 down in KCPA and 3 down in KCP. KCPC is not running in this particular situation. It shows you the total power consumption for the day, how much water has been consumed, and also calculates and shows us the amount of carbon being emitted from that plant. There's another screen grab showing us the power distribution and the water usage in the various kernel crushing plants A, B, and C. So you can see hardly ran, so it's almost zero. And the power consumption for the various plants are also captured here. KCP A, B, and C. C, although it's not running, you'll have some lighting and all that. So there'll be some consumption in this plant as well. Some more screen grab showing you how they monitor the presses. This is press running at alert levels. It's not good. This is too low. That means it's almost like running empty. That is a live reading taken at a certain time, right? So this will send a message to the operator's handphone via telegram, informing him that it is not running optimally, and for him to see whether it is underfed or whether it's blocked and nothing is going into the press. If it is operating between 40 to 75 amps, it's considered as satisfactory. Some more screen grabs of various things are monitored in the plant using the system. We did it for this plant because this plant is a highly mechanical plant. It didn't have any PLC or DCS in the system. So we wanted to start harvesting data. Then once we have the data, we look at how we can optimize the plant operation. We've already started implementing some things, but there's still a long way to go to improve the plant further. Okay, now I said I'll also share with you what our achievements of greenhouse gas emissions. You see that we used 2015 as our base year, and this were the levels, 23.65 kg per ton of product was our emission for the refined bleached hydrolyzed palm oil. And you'll see that our efforts over the years, we've been reducing it, and as at the latest, we have achieved 15.4 kg per ton. For the olein and stearin, from the initial 14.84 kg per ton, we managed to reduce it all the way down to 5.68 kg per ton. This is the lauric oils. The gray one is the crude palm kernel olein and stearin, where our baseline is 31.35 kg per ton. It has dropped to almost half, which is 16.4. And for the refined oils, from 23.73, it's dropped to 14.55. You'll see that our base year, the intensity was 45 kg per ton of product. And we have managed to drop it to, in the year 2023, to 23.6, which is already exceeding our 25-26 target and in track for us to achieve our 30-31 target. In our case, it's mainly CO2. We have no methane, no nitrous oxides, and we've also migrated our refrigerants towards more friendly types of refrigerants. Now, I wanted to share this with you to show some circularity within the palm oil industry. This is going to start from here. This is the top left-hand corner, which is from the palm oil estate. You will see the fresh fruit bunch being harvested, that is the FFB. This is sent to the mill. In the mill, this is processed to produce CPO, crude palm oil, and palm kernel. Right? In the process, they produce a lot of effluent, which has got very high organic matter content. And the fresh fruit bunches are shredded to produce chopped empty fruit bunch. Okay. Now the effluent plant, where the high organic matter is sent, actually is now modified in order to become anaerobic digesters, where they generate methane, and that methane is sufficient to generate or to supply the boilers to generate steam, as well as to generate enough bioenergy or green energy to power the whole mill. And they even have access actually to supply to neighboring estates and housing or any other requirements nearby. The crude palm oil and the palm kernel goes off to refineries like ours or conversion plants where we produce crude palm oil and crude palm kernel oil. These go through the refining process to produce refined bleached and deodorized palm oil and refined bleached and deodorized palm kernel oil. I explained earlier, the effluent water goes through a closed loop and is recycled. Now here, I mentioned we use bleaching earth. That spent bleaching earth actually contains 20% of oil in it. That is then sent to specialist companies where they recover the spent bleaching earth oil, which is used for non-edible purposes, mainly for lubricants or for detergent use. And the de-oil bleaching earth can be used as soil conditioner and sent back to the estates. Now the chalk EFB comes to my biomass plant here, which is used as a fuel to generate steam and electricity to supply the needs of the entire complex, right? And once the EFB is combusted, the ash that comes out, the boiler ash, has got a very high potassium content. And that goes back to the palm oil estates as fertilizer. So you can see the circularity within the palm oil industry. There's not much waste in the industry. Even the trunks now, there are industries that use it for making furniture. Now, more than 70% of palm oil is used in food applications, which I showed you earlier. About 20% for household products, lotions and conditioners and all that, and about 10% for biofuels. Now, in your daily life, right, you would have come into contact with palm oil at various stages, whether it is from bathing. During bathing, many popular shampoos and soaps and conditioners all contain palm oil. Your toothpaste, again, contains palm oil. Your personal care products, such as your deodorants, your shaving creams, your cosmetics, your lipsticks, again, contain palm oil. Your breakfast, very often, you fry with an oil that's palm oil, or even your cereals. Many cereals and spreads actually contain palm oil or made with palm oil. You've got pets. Again, your pet care contains palm oil in it as ingredients. Lunch, a lot of restaurants use palm oil for their cooking. Same again for dinner. Your snacks, a lot of confectionery, a lot of ice creams, a lot of cookies, bakery products contain palm oil in it. Your washing up liquid, your cleaning liquids. So throughout the whole day, you have come into contact with palm oil. So it plays a very important part in your life. And some of the health benefits of palm oil, there's vitamin E, which is connected to improve brain health. And also a lot of antioxidants in it. It also promotes heart health. The vitamin E in palm oil also promotes heart health. And also palm oil contains, I said the beta carotenes, the orange color in palm oil is actually the provitamin A, which you can absorb. And it is good for eye and general health. So if you look at our golden oil, palm oil, it contains all these very, very important ingredients. Now, in the refining process, this is crude palm oil. These are the contents of these nutrients or antioxidants that is in it. In the refining process, depending on how you run refining, some of it is removed or destroyed. So you'll see that it is lower than what is contained in crude palm oil. Much of it may go to the palm fatty acid distillate or may just be destroyed. So this is another area to look at for plant design projects, to look at how you can maximize extraction of these vital ingredients to improve the quality of the refined oil. So that it actually has got higher contents and makes it a healthier oil. Okay, these are some of the awards we won. Best Kernel Crushing Plant, National Energy Awards in 2018, 2021, 2022. First runner-up at the ASEAN level, right? Again, winner for Renewable Energy category. There's the IOI Group Innovation Award. We were the winners for the downstream category. National Energy Award runners-up for the Malaysia and also ASEAN level. And then winner in the special category. This is my team here who contributed to this presentation. Thank you.